All right, we are going to solve problem 22 on the practice final exam. The question is asked to find all values of x such that the output functions f of x and g of x are the same, meaning what are the input value of x as we plug in to these two functions, so that the y values come out to be the same. That's what this f of x equal to g of x means. So to solve the problem, we simply just said, okay, well, let's start with this. In order for us to solve the value of x, let's start with what f of x are, what g of x is, and then set them equal to each other. So f of x is 3x plus 1, g of x is x plus 28, square root minus 1. So this is from chapter 7, solving radical equation. If there's two radical terms, we want to solve this by squaring both sides twice. We always want to have one side of, starting out by having one side equation where there's no extra term, it's just a single radical term. So when we squaring things, one side will eliminate the radical right away. So let's start with that. So we're going to square both sides. And when we square both sides, the right-hand side, it becomes a FOIL, situation here. Is this time itself, and that's something that I would highly encourage you to write this step out like this here. To remind you that we are foiling these terms. Square root x plus 28 minus 1 time itself. So the result of that is, FOIL, first, outer, inner, and last, right? Left-hand side remain the same. Right-hand side, we have a square root of x plus 28 times square root x plus 28. Maybe write this step as this here to kind of, remind yourself that, okay, this is just square for the first term. And then as you FOIL, you get this here. You get this here. That's just a negative square root of x plus 28. And then this here is another negative square root of x plus 28. And then negative 1 times negative 1 is plus 1. Okay. So now we clean it up. 3x plus 1 on the left-hand side. That cancels. That just x plus 28. I'm going to bring this over there. So plus 1. Twice of this, because that minus itself, it's going to be twice of that. So minus 2 radical x plus 28. So I am going to bring all these terms the other side and leave this on the right-hand side. So 3x minus x is going to be 2x. Negative 1 minus 1 is going to cancel each other out, so we're just going to have a negative 28 on the left-hand side there. So now we end up with this. So we can divide out the 2, since the negative 2 goes evenly into both sides, so we can divide out that negative 2 or divide the 2 if we want. We don't want to divide by negative 2. The problem with that is if you divide by negative 2 here, then you end up with a negative in front of x, and we don't want to do that when we're squaring it. So let's just go ahead and divide the 2. Clean this up a little bit, lower the coefficient value, so we get x minus 14. That canceled, so that just gives us a minus square root of x plus 28. So now we end up with the equation where one side has a radical term by itself. This allows us to square both sides again. So this squaring is going to eliminate the radical term on the right-hand side. The left-hand side, we are FOILing that out. So I will just remind you, this is what we're doing. Write this step down here. So remind you. On the right-hand side, that time itself, so meaning square root square is going to cancel out. The negative is going to make it positive because anything negative square is going to be positive. So we end up with x plus 28 on the right-hand side. Left-hand side, we are going to distribute x squared minus 14x minus 14x. 14 times 14, 6, 5, 4, 1, 196. So plus 196 equal x plus 28. I'm going to go ahead and bring everything to the left hand side. So that gives us x squared minus, so this would be a minus 28x, subtract x, so minus 29x. And then we're going to subtract the 28 from 196. So that gives us a positive 168 equal to 0. Okay. I think we can factor this. If not, use quadratic formula. So try factor first, or use quadratic formula. Okay. The reason why I'm thinking we can factor this is because 168, I think this can divide by 8, because the first two digit divisible by 8 there. So that would give us 2. No, it doesn't. Does it divide by 8? Let's see here. Let me just actually do the division here. Then guessing. 8 divided to 168, 2, 16, 0. Bring down the 8. So that's 121. Okay. So 168 is 8 times 21. And does that give us 29? Yes. Okay. So we can say this fraction to x minus 21. And then x minus 8 equals 0. So that means x equal to 8. X equal to 21. Now the problem with this process is, as we start with this equation here, right, these equations have defined domain on certain x that make these functions defined. As we solve these for x, we are squaring it, and then we're squaring it. So we square it twice. Sometimes when we square things twice, we bring an extra value of x that is not part of the original domain of these functions here. So we have to check. These could be extraneous solutions. So one of these could be extraneous solutions. So check. Okay. So I'm thinking the 21 is going to be extraneous. Why is 21? Why is 8? I think one of them would not work. I don't think both of them is going to work. Okay. So let's try 8. So x equal to 8. So we're going to get square root of 3 times 8 plus 1, I believe. Yes. And then over here is equal to 8 plus 28 minus 1. So we get, what, 25 there. So that's 5. And then we get 36 minus 1. So 5. No, this is 6. 6 minus 1. So that's 5. Okay. So that's just, so 8 is correct. Let's try 21. X equal to 21. So square root of 3 times 21 plus 1 is the same thing as square root of 21 plus 28 minus 1. So this is a square root of 36, 360, 364, 59. So this is 8. That's not the same thing as square root of 59 minus 1, because square root of 59 minus 1 is not a even number. So I think the only answer we have is x plus x equals 8. Now, what does this mean in terms of is the two graphs? Okay, let me graph them and kind of show you what the solution looks like in terms of the graph here. So where is my graph? Decimal. Okay, decimals. So one function, y equal square root of 3x plus 1. Okay, that's one of the graph. Okay, that looks like that. And the other one, y equal square root x plus 28 minus 1. So it looks like that. Okay. Looks like the two graph, the blue and the red graph crosses. So this is what we're looking for here. We're looking for that y value when both y values are 5, the x that give that the two output are the same is when x is 8. So when you click on it, it kind of show you what that intersection point is, okay?